Okay, looks like I'm going to go ahead and get started here. I will give a few minutes, but I'm going to talk about what we're going to do today. What we're going to do today is a little bit different. I've been showing you C sharp. Hopefully everybody can hear me all right. I don't have my normal testers, I don't think. But anyway, um, what I'm going to be doing today is a little bit different. I'm going to go ahead and show you a little bit of Python, but we're going to build a thing. We're going to have a purpose for our Python. So I'm not going to get into a lot of particulars about how Python works. I'm going to show you how to make this work. So this is a Raspberry Pi Zero W, the 2017 model, not the 2, which works just fine. As a matter of fact, it's actually a little bit overkill, really. You could do this with a Pico W, but with different, you'd have to do some pin adapting. Doesn't matter. Maybe I'll do that at some point. But this is an 8-channel relay board, obviously. So I am going to make this work with Home Assistant in a very simple way that does not require additional plugins, add-ons, anything like that. You just put some code on here, put this on your network, and you've got some switches that will set up in Home Assistant that will be able to turn these relays on and off. So this is actually one of the reasons why I'm doing this now. This is the old Pico thermostat, the first one that I built, and I wanted to do something that was a little bit smaller, so I switched to, I'm sorry, it's the old Raspberry Pi thermostat. I wanted to switch to something smaller, so I went to the Pico. This is obviously the Zero. So this is the original thermostat, and it served me perfectly fine for a year. There's nothing wrong with it. I just wanted to do something different, and admittedly, the 8 relays was a bit much for a thermostat. I still obviously have the jumper wire here to jump the hot to all of the relays, the 24 volt. So, and I still have the DHT22. We're going to go ahead and use the DHT22 later, and you can have feelings about that. That's fine too, because I've heard a lot of people say, well, they're not very accurate. I have found them to be just as accurate as most of the digital thermostats that I have in the house, including the Govee thermometers that I have all over the place, and the original digital thermostat, which is hanging over on the wall. So the DHT22 for me, it's perfectly fine. I think for anybody's general use, it's perfectly fine. You could probably even use the onboard sensor, but I find that it's usually just a bit warm because it's right near all of the hotter electronics on the board. So I am going to, oh, the other thing, I am not going to show how to image your SD card or set up your Wi-Fi for headless or set up SSH to get in there. I'm going to assume that you, like me, have a pre-cooked version of this that already has the image installed, and you can already SSH into it. The only additional library that you will need, and this is if you decide to use the DHT22 part of this, the only additional library that you'll need is the Adafruit DHT library, which is linked in the description of this feed. So let me go ahead and switch over to my picture-in-picture mode here. And I am going to start by secure shelling into the Pi. Oop, doggone it, I accidentally hit enter. There we go. Okay, now I already have the necessary library installed, so I'm just going to go ahead and dive right into creating some code here. This is going to be a really easy script because every programming language that you work with will have a set of pretty commonly available libraries. One of the most common is the ability to send and receive, or to send HTTP, get, post, put, delete, etc. requests. So we are going to be doing some getting and some posting. What do we want to make? Let's call it 8 relay pi. Okay, so the first thing that we're going to want to do is import time. Now, what I'm about to do next might be hacky. As a matter of fact, I'm certain it's hacky. It's probably not the best way to do this, but it's the fastest and it's always been reliable for me. Because certain things are not available at the time that reboot commands actually hit in cron, sometimes your Python scripts can fail if you're running this on startup. So I always add a time sleep, and I usually add 15 seconds for proper Raspberry Pis, and I add 30 seconds for the 0 because it tends to be a little bit slower. I've not played with a 2 yet, so I imagine that it'll be faster. And then we're going to import, let's see, what else do we need? We need the requests library that will allow us to make HTTP requests. We're going to import the JSON library because we're going to need to do some stuff with that in order to send, excuse me, in order to send data to Home Assistant with the temperature information. We're going to need the JSON library. And then we're going to need the Adafruit DHT library. What else are we going to need? Oh, the GPIO library. Right? Yeah. Wow. Can't type today. And we're going to import that. I am cheating again. I have some reference snippets up here. So if you see me looking over here, that's why. The next thing that we're going to do is, so there's 8 states and there's 8 pins. This particular board, if you pick this board up, which I believe is $34, I really like it because it's on this DIN rail, and it's a little steep, admittedly, on price, but I've used it a lot. So it actually tells you right beside the jumpers. Most of these kind of boards that you find that have a header for the Raspberry Pi will tell you what the pins are on the little jumpers here that you can take off to make it, work with just the manual inputs. So this one is on, well, I'll just show you the list. The pins that we are going to be dealing with, there we go, are 26, 21, 20, 19, 16, 13, 6, and 5. So because of the way that this board is built, you can actually access the other pins. You could probably even get away with multi-purposing pins, but I'm not going to get into that kind of thing. So the other thing that we're going to do is, in order to talk to Home Assistant, you will need to go into your settings. I'm not going to go through this part either because I've already done it and I'm really lazy, but you can look it up. You have to go in and get your token. So once you have your token, you can send API calls, send and receive API calls with Home Assistant. Actually, you know what? It's probably not that big of a deal. I believe that it's in the development settings, which, this may or may not be the correct way to get to here either, which I don't even remember where I did that. I thought it was in the oh, here, developer tools. And then we go to somewhere. You know what? I'm going to have to look it up. Long-lived access tokens. This is what we want. Which, on the profile page. Oh, okay. You have to go in here. I see. And then, right, all the way to the bottom. Okay, so you go into the, I'm sorry. That was a big, huge waste of time. So you just click on your user and then you go all the way to the bottom in the profile, and here are your long-lived access tokens that you will need. I have already put mine on the Pi in its own file so that if I ever put these scripts on the, excuse me, I actually have a cold. So if I put these scripts on the Git repo, I'm not putting my secrets on there. So what I'm going to do is I am going to open a new file, or open the existing file, excuse me, create a new file object. Where do I have that? Oh yeah, and I just have it as there. And then I'm going to say HA token. So this is something that's a little bit different if you were here for the C# stuff. In Python, you kind of get away with doing things. Oh, and you know what? I shouldn't use tabs in here. There we go. You can get away with instantiating objects inside of things like this, and it's not bad. I actually don't understand how it does that, so please don't ask me. Python is, I've always just sort of accepted that it's magic, and I've loved it for that, and that's pretty much it. Okay, so I'm just going to read the contents of the file HA token and strip off any white space in case I hit enter at the end of the token. Oops, I don't need to be okay. The next thing that I'm going to do is I'm going to set up an array of booleans so that I know what the states are. I could check the pin every time, but I don't like to do that. So yeah. Is that 8? That's 8. Okay. So the first thing that I'm going to do is I'm going to set the GPIO mode so that we can use the pins. I'm going to do set mode, GPIO BCM, and then we are going to instantiate, or I'm sorry, set up all of the pins as outs. So for pin and pins, okay, so oops, tag on it. There we go. Okay, so that's going to set up all of our pins that are specified in the array above to output. And then we're going to create our set circuit function. We're going to give that a channel and a state. This is what we're going to call later to set the pins high or low, to turn the relays on or off. Let's see here. You know what? I'm actually just going to copy paste this because it's a big chunk. Oh no, that's not what I was looking at, but I'm going to copy paste this too. Okay, so all I'm doing here is just accessing the global state so that I can set it at the bottom. If the state is false, I'm going to bring the GPIO high. If the state is true, I'm going to set it low, or if it's anything other than false. So if it's set, basically. So the reason that I'm doing that, on this board, the pin, like if you bring it high, it shuts the relay off. So I know that's weird, but that's just the way this board is. I could probably fix that, but I don't really feel like soldering and doing things to the board. So the next thing that we need, is a get state function. So again, I'm just going to paste these in here in chunks and explain them as I go. That way, you know, I will make this code available later, but that way we get through this part and get to the Home Assistant part, which is really not that difficult, but it's probably the thing that, you know, you don't know about yet. So here all I'm doing is I'm making a GET request to my Home Assistant's API through the IP address to get a input that I am going to set. That's the trick here. I'm going to set up a helper that this can then check through the API, and every second it'll just check those states and then flip a relay on or off. The next thing that I'm going to do after that is throw in the send state. So this is a little bit, this looks messy, but it's not all that bad. It's just because there's two sections. I could have done this differently as well. I just copied and pasted the entire bit into, okay, why are you not scrolling down? Oh, that's awesome. Okay, so hopefully that's still... Ah, crap. I'm just going to move myself up there. Okay, I did not realize that you guys could not see. That's awesome. Did it again. That's the second time I've done that. Anyway, so as you can see here, we have the GET request to the API. We're sending the bearer token across. That's just how we authorize. That's what your long-lived token is for. I'm not going to get into basic authentication. And then here in our send state, this is where we're going to send the value for our sensor. Home Assistant expects this to be a certain way, and since we're sending in a numeric value, we can also give it a unit of measurement, which is actually super useful if you want to do other things with it. I just display it, but so if we have a sensor, a temperature sensor reading, we're going to send it to the thermostat temperature sensor. So notice this is not an input, it's a sensor. And then for humidity, we do the same thing. And we just change the unit of measurement, and we just change this to humidity. Other than that, the two are the same. That's duplication of code that's unnecessary, but, you know, sue me. Okay, so what else do we need? We have our get state, we have our send state, we have our... Oh, we need to be able to read the sensor. So the next thing that we're going to do is put in a function that lets us read the DHT22 sensor. And this is pretty easy as well. It just uses the Adafruit DHT library, has a read retry. I believe that this will hit, I think this is the retry count here, and I believe it hits every 50 milliseconds, something like that. I can't remember exactly, but anyway, it just retries this many times, and then if it fails, it gives you none values back. So if they're not none, we're going to do this thing. This is the calculation to convert Celsius to Fahrenheit. Sorry, for those of you who are Celsius. And then we just do the send state twice, once for the temperature and once for the humidity. I do not know of a way to send multiple states simultaneously to Home Assistant. If you do know, if that does exist, let me know in the comments, because that would be really cool. I'd love to be able to send multiple sensor states in one call rather than having to make numerous. Okay, so the next thing that I'm going to do, this is actually going to be the top of my script. I didn't put a main in here, so I'm kind of bad. Usually you're going to want to put in some, you know, one of these, let's see here. Oops, I did that backwards. And this is what the entrance to a Python script normally looks like. But I didn't do it in my reference, so I'm going to have to go through and tab these out. So this is just iterating through and setting the circuits to low in the beginning. You wouldn't necessarily have to do this. You could always save them. You could save them in a JSON file or something like that, or just a flat file with comma separated values, or even just one character at a time values, and then just recall them whenever you loaded the program. I didn't go that far here. I did do one thing up here. I probably should have sort of explained that. Where is it? Ah, right here. In the get state, if the request fails to get the state from Home Assistant, it will just default to the last state that it knew. So I could see situations where that might not be, you know, the best idea, but you really shouldn't be using this for those kind of things anyway, right? I'm thinking, you know, this is going to be for Christmas lights or something like that, you know, lights out on your deck, maybe some landscaping lights. Nothing super high, although the relays that are on this particular board can actually handle 10 amps. I would not put that through them, and I would not trust the terminals that are connected to them or the breadboard that they are soldered to take that kind of abuse. But the relays themselves would be fine. So that's another thing that you should always consider whenever you're building something like this. Even if your components are rated for a specific number, that does not mean that the combination of all of your components are rated for that. You should always look for the weakest link. Okay, so I'm going to put the last bit of code in here. This is the loop, the while loop that I have to go through. Oop. Scroll lock. This is the problem with doing it in Nano. But I still stand by it because I love Nano. Did I just paste that in the wrong place? I did. Okay, back that up. Awesome. So while I'm backing this out because I don't know the keystroke for deleting full lines in Nano, all that we're doing here is just running through, doing a check for each of the pins, and then setting them if they're different than the state we last knew about. I'm going to go put my cursor in the right spot, and I'm going to just go ahead and tab this before I paste it. Okay, there we go. So here we're checking the state, and then if it's different than the state that we knew about, we're setting the circuit, and then we should be, inside set circuit, we set the state. So we don't need to worry about doing that here. And then we sleep for 1/8 of a second. And then if the R count that we have up here is 24, it will reset and run read sensor. That will happen approximately every 3 seconds. So not exact, but close enough for what you might use this for. So I am going to go ahead and save that by hitting Control-O to overwrite. I don't know why it doesn't like being zoomed in. Okay, and then exit out of Nano. And then I'm going to go ahead and run what we just built. Oh, daggone it. See, this is another thing about having, a nice thing about having an IDE. It shows you when you made stupid errors like that. Okay. Oh, okay. You know what I'm going to do? I am going to just run the one that I already prepared. So goodbye, Movie Magic. Except I can't remember what I named it. Where is it? Oh, this is riveting, I'm sure. Did I not save it? No, there it is, new thing. Okay, so I'm going to run new thing. And then it's going to wait 30 seconds because I didn't comment that out. And then after that 30 seconds, it's going to reset all of the relays on here, which you may or may not be able to hear them click when it does that because they're not on presently. And then we are going to go over to Home Assistant, go back to our settings, go to our devices and services, go to helpers. There's a fast way to get here. There's another YouTuber that I was watching that does some sort of keyboard command that brings up a quick input, and then he just types in the area that he wants to go to, and it jumps to it, but I don't know how to do that. So if you're like me and don't know how to do that, that's how you get here to the helpers. And then I'm going to create a toggle helper, and I'm going to call that toggle helper 8 relay CH1, like that, because it will automatically create this input underscore boolean dot 8 underscore relay underscore ch underscore 1, just like it is in our script. So I can then close that, and then you go through and you set that up for 2, 3, 4, 5, 6, 7, and 8. I'm not going to set up each one of them because it's not really necessary for me to show you this working, and I don't want to bore you any more than I already have. So on that note, I don't know that I'm going to continue doing the streams. I think I'm going to I don't know. There didn't seem to be a whole lot of interest the last time. I don't think that, I'm not sure if it's just that I'm not exciting or if there's something else that you'd rather see me talk about. Um, but let me know in the comments either way. So now that I have this set up, I should just be able to flip this and you can watch it change. Where's the camera? And there it goes. So there will be a slight delay, right? So if you hit the button and it just happens to be at the top of the second before it rolls around to that particular number's turn, it could take up to a second to do that. But still, that's really about as fast as you'll get from most. Okay, it's about to prove me wrong. Nice. Nice. Thanks, Raspberry Pi. Interesting. All right, I'm going to have to, oh, there it goes. I think I'm just having, so I have way too many Wi-Fi devices, and all three of my Wi-Fi networks are freaking out about it. I bought a Ubiquiti U6 Pro to try to fix the problem, not realizing that they would hold me hostage by only allowing me to have the most basic wireless access point functionality unless I spent another few $100s on their gateway. To be fair, they are an enterprise thing, so they're really meant to be a larger system. But it didn't quite go as planned, so I do have some Wi-Fi hiccups, and that could be the delay. But the other part of it is you might as well just kind of accept that most IoT things are going to be about that dependable. And if you think that your IoT device is more dependable than that, you're probably in for a bad day someday. Always, always, always assume the worst. But again, if all this is doing is turning on some ambiance or some Christmas lights, it's really not that important. I would not hook up, grandma's oxygen concentrator to this. That would be bad. So that is pretty much it. That is all it takes to use a Raspberry Pi and a little bit of Python to set up a relay controller through Home Assistant without having to go through ESP Home or without doing any of the other kind of installing add-ons and then going through 5 billion different layers to get a UI. Not that I'm talking about anything specific, Sonoff NS panel, but yeah, so that's all there is to it. If you'd like to see me do more of this kind of thing, let me know in the comments. Let's see. I have not been paying attention to the chat because that's just how I roll. Yeah, I was wondering if I was a little bit quiet. I sound quiet in my monitor, but then I was like, I don't want to move closer to the mic just in case the people that have already joined have turned their volume up, because I feel like that would be sort of a bad move on my part. But anyway, yeah, so one of the reasons why I like doing things like this is it's not that I avoid ESP devices or anything like that, but with just a little bit of Python, what I have now is something that should work so long as Home Assistant's API works as simply as it does for the thing that I'm doing. And I'm pretty sure it will. I don't see them changing that, but I do see ESP changing. I do see all the add-ons changing. This, you just need a helper. And this Raspberry Pi will run this Python forever, or until it dies. And that Python will work because it's using HTTP GET and POST requests, not some weird obscure technology from the mid-90s that was borrowed from the industrial or commercial world and will probably just kind of pass like all the other trends within the next 5 to 10 years. HTTP has been around for a long time. The technologies that the Raspberry Pi allows you to leverage have been around for a long time. that's also true with the ESP32 in many ways. But the things that I build, I I tend to do a little bit overkill. I tend to spend a little bit more money on devices because you can get you know the ESP32 stuff is actually cheaper than the Raspberry Pi stuff, but I have less issues with everything that I build than a lot of other IoT implementations. I'm not saying that to dig on anybody else's work or setup, but you know, the less steps or the less points of failure, the better. Anyway, so that is all I have for you this week. Next week, I am going to attempt to do something a little bit more exciting, try to be a little bit more engaging. If there's anything that you would like to see me do, again, let me know in the comments. I keep having to say all these YouTuber things because I have no other way of reaching out. This is my way of reaching out. I've tried using posts. Nobody seems to like those. Try live streams. Nobody seems to like those. I'm not on social media anymore because, frankly, it's a dumpster fire. So I don't have any interest. And that's not like, you know, this is not a political thing or anything. It's really just, I want my 90s forums and flame posts back. As a matter of fact, if we could go back to news groups, that would be even better, in my opinion. Multi-user domains for life. But yeah, so not on social media. This is the way that I communicate with my viewers, provided you're watching in the first place. So do me a solid and let me know if there's something that you think would be cool, because I'm here to please. So until next week, thanks for listening to me ramble. Thanks for sticking with me this far. I do hope you'll join me for future videos and streams as I continue exploring and building smarter circuits.